Hello scholars, welcome back to our YouTube channel. Now we'll be moving to derivation of OLX using 3 variables. So in our last class we deal with OLX using 2 variables. Now we are moving a step ahead to 3 variables. Like we did for the 2 variables, the first thing you have to do is to specify your function. Then after specifying your function, you have to specify your mathematical model. Then after specifying your mathematical model, you need to specify your econometrics model. Now here we go. We have y equals to function of x. So this is my function model. This is the specification of the function model. Then after this, we can have the specification of the mathematical model, which is going to be y equals to beta naught plus beta 1 x1 plus beta 2 x2. Now at this point, we are no more dealing with 2 variables again. We are now dealing with 3 variables. So the variables, the parameters that we want to estimate, it is your beta naught, your beta 1, and your beta 2. Now in this case, this is 3 variables. Now let's specify our econometrics model. And our econometrics model is going to be beta naught plus beta 1 x1 plus beta 2 x2 plus the error term. Don't forget that this stands for the error term, and in our last class I explained what the error term means. I said error term captures other variables that affect the dependent variable that we cannot cover. When we are having the theoretical class of this, I'm going to explain that better, but now we are proving, so I don't need to explain much about the theory. What you just have to understand about the proving are the steps before you arrive at the estimation of the parameters that are here. So the error term that we introduce here make it different from the mathematical model. So the error term present here make this model to be econometrics model. So now let's move on. Don't forget that let me just recall that your error term equals to the population minus the sample. That's what gives us the error term. Then what is your sample? Your sample is your beta naught plus beta 1 x1 plus beta 2 x2. This is what you have for the sample. Then by having this, I need to get my error term. Don't forget, your error term can also be called the residual, and it can also be represented by you or he. So now I can now arrive at this, whereby my error term is going to be my y minus my sample, which is this. Then I'm going to have the bracket of this. That is, I'm going to have beta naught plus beta 1 x1 plus beta 2 x2. Then I close the bracket. By doing this, I need to use this negative sign to open this bracket. I hope you understand. So your error term here will now be your y. Once I also put through the negative sign, this one is going to be minus beta naught, minus beta naught, minus beta 1 x1, minus beta 2 x2. This is what you are going to have here. Now, then after getting to this point, what you need to do is to add the square, and sum to both sides. This is what you have, you add the sum and square to the both sides. What do I mean by this? Add the sum, add the square, means square your error term and square the other side. What is my other side? It's this. You need to square the both sides. You have this, you have this, you have this. Don't forget, if you have any questions or anything you don't understand, just drop it in our comment section. So you have this. Let's move on. I thought I explained that I need to add the square to the both sides, which I'm going to have this. Don't forget. Then at the same time, the sum to the both sides, which I will have this, I'm going to have this. I'm trying to simplify this in the level that everybody is going to understand on this channel. So when you get to this point, the next thing you have to do is to differentiate with respect to the parameters or the coefficients you are looking for. Now we are looking for the coefficient of beta naught. So in the sense of looking for the coefficient of beta naught, I need to differentiate with respect to beta naught, where I'm going to have the summation of error term square with respect to beta naught. So I'm going to differentiate the summation of the x square of the error term with respect to beta naught. Having this is going to give me minus 2 summation y minus beta naught minus b1 x1 minus b2 x2, which is going to equal to 0. Sorry, don't mind the size of the board. So this is going to equal to 0. Now in that case, that means I'm going to have minus 2 summation of y minus beta naught minus beta 1 x1 and minus beta 2 x2. Don't forget, we equate it to the 0. Then when you get to this point, the next thing you have to do is to eliminate this negative 2. By eliminating it, you have to divide the both side by minus 2. And when you divide both sides by minus 2, I'm going to have this 0 divided by minus 2. I'm going to have summation of y minus beta naught minus beta 1 x1. I'm going to have minus beta 2 x2. Close the bracket. I'm going to have 0. Here we go. This is another step of the equation. Now after eliminating the negative 2, I arrive at this. Now don't forget that the parameter we are looking for here, it is your BO, which is the beta naught. Don't mind me, I can use BO, I can use beta naught. Just understand that I mean the same thing. will use the summation to open this bracket, where I'm going to have summation y minus summation bo. Then I'm going to have minus summation b1 x1. Then I'm going to have summation minus summation b2 x2, which is going to equal to 0. So I've not done anything here than open this bracket. So I open this bracket, I'm arriving at this situation. Now the next thing I have to do is to take this guy out of the feed. So that by taking this guy out of the feed, because this is what I'm looking at for, my target is this. So by taking this guy out of the feed, by moving this to the other side, this negative sign returns to positive. Then I'm going to have summation bo, which is the beta naught, which is my constant, is going to give me summation y minus summation b1 x1, then minus summation b2 x2. Now, in the process of derivation of this thing, I want you to note these points. I'm going to name these points my equation 1. Oh my god. Don't worry, I'm going to put 1 here. This means this is my equation 1. Because when we get to a point that I need to get my beta 2 and beta 1, I will have to make use of this equation. So I'm going to make reference to this equation. That's why I'm noting this now as my equation 1. Now let me continue solving this. So I have my summation of beta naught to be this function. And by having this, don't forget that your summation of beta naught is the same thing as you have n of bo. So therefore, I'm going to have n of bo, which is my number of the beta naught, is going to equal to summation y minus summation b1 x1 minus summation b2 x2. Here, I cannot divide both sides by n. I can divide all through n. Then this is cancelled. It's going to cancel this. Now, at this point, I've arrived at the value of my beta naught parameter. Then, by having this, excuse me, sorry. So by having this, I'll need to rub this off, please. If you have not, probably you have not screenshot this, please try and screenshot this. Very soon we are going to expand our board so that the whatever derivation we have to do is going to be convenient for us. So let me just rub this off now. Now we are at this point where our beta naught is equal to summation of y over n. And I can bring this out to be having beta 1 summation x1 over n minus beta 2 x2. Sorry. I want to bring this beta 2 out. Then I'm going to have x2 over n. So I can represent this, my beta O, as bar y minus beta 1 bar x. Yes, I can have this. Then don't forget beta 2 bar x2. So here I've derived my what? My constant. I've derived my constant, which is this. Now I'm left with my slope, which is my beta 1. Then I'm left with the slope 2, which is my beta 2. Then don't worry, I'm still going to get it. Okay. Now, note that I told you to note this equation, which we represent this equation as equation 1. So this equation is going to be useful for us to derive our beta 1 and to derive our beta 2. So here, please do well to screenshot this because I need to rub this thing up. So this is my equation 2. Let me work here. Probably I'm going to get my equation. This is my equation 1. So let me look for beta 1. Probably I'm going to get my equation 2 with this space. Don't forget that for me to get my beta 1, I will have to start my journey again from here. Because the journey to solve for beta naught is coming from here. Therefore, the journey to solve my beta 1 and my beta 2, we also have to start from here. So let's start the journey for beta 1. So the journey for beta 1 is now, I'm going to differentiate this. I'm going to differentiate this. I'm going to differentiate the summation of the square of the error term. Now, not with respect of beta naught again. It's now going to be with respect of beta 1. So with respect of beta 1, so by doing this, I'm going to have the differentiation of this. Then I'm going to have minus 2 summation x1 because I'm dealing with this. That's why I'm having minus 2 summation x1. So minus 2 summation x1, you open the bracket, you have your y, you have your beta naught, you have your b1 x1, then you have your b2 x2, then you equate it to the 0. Don't forget that when we get to this point, when you equate to the 0, don't forget that what you need to do now is to divide through by minus 2. So in the process of dividing through by minus 2, you have this. You have this guy. You have this guy. You have this guy. Then you have this. Then divide through by minus 2. So this is eliminating this, and this is going to give me 0. So therefore, I'm having x1. You open the bracket, y minus b beta naught, which is bo, whatever you call it. Then this is beta 1 x1 minus beta 2 x2. And this is equal to 0. Now, what you have to do here is to open the brackets with this that is outside. So I hope you understand. And I said that if you don't understand, just drop a comment at just drop your question at the comment box. Then I'm going to reply to that. So here, I need to open the bracket through this. So in the process of opening the bracket, I will be having something like this. Summation x1y with this. Then with this again, I'm going to have minus summation x1 beta naught. Then with this again, I'm going to have minus. I've used this to multiply this, I arrive at this. I use this to multiply this, I arrive at this. Then now, this is summation x1 multiplied by this. In that sense, I'm going to arrive at what we call summation x1 squared. So I'm going to arrive at summation x1 squared because this is x1 multiplied by x1 is going to arrive at square. Then don't forget that we have our beta 1 here. Then I'm going to use this to multiply this 2. I'm going to have minus summation x1 x2. Then what is my beta 2, which is equals to 0. This is another equation now. So I'm going to label this as my equation 2. Please don't mind the size of the board, like I said. So don't forget that we labeled one as equation 1 here. So here we are labeling another one as equation 2 at this point. So this is my equation 1, this is my equation 2. So here I need to arrive at my equation 3. So, but I also need to screenshot it because I need to clean this looking off. Okay, I'm going to clean this side now, and I can continue to find my equation 3. Yes, this is my equation 1, this is my equation 2. Now I'm going to equation 3 now. So don't forget that the journey of beta naught and beta 1 is starting from here. Now here I will need to differentiate with respect to beta 2 now. So in this point, I'll be having differentiation of, I will differentiate summation of the error term square divided by with respect to beta 2 now. Now we are dealing with beta 2. This is beta 1, now this is for beta 2. So for beta 2, what is going to happen here is going to be minus 2 summation x2. It's not going to be x1 again. Minus 2 summation x2. You put the brackets, you put the ingredient there. What are the ingredients? These are the ingredients. If it is possible for you to talk there, from when you are watching the video, I'll listen to whatever you're saying. Then I'll be dropping like any updates or any correction. So this is y minus this. Then I'm going to have this too. Close the bracket. Don't forget that it's because of this board. You need to equate whatever your equation is here to 0. And which is going to, I'm going to arrive at this. Minus 2 summation x2. Open your brackets. Y minus beta naught minus beta 1 x1 minus beta 2 x2. Then you equate it to be 0. That's what we are having now. You equate it to 0. Now the next thing you need to do, you need to eliminate this minus 2. Then you divide both sides by minus 2 again. The same process, just the same process. So this is going to give us this. Then you open the bracket, you have y minus beta naught minus beta 1 x1 minus beta 2 x2. Close the bracket, you have 0. I'm sure you understand, and you will understand. So I'm still going to make reference to equation 1. I'm still going to make reference to equation 2. So what I'm working out here is I'm working out my equation 3. Then I'm setting all these equations so that it's going to be easy for me to get my beta 1 and my beta 2. Along with the process, we have already get the constant, which is my beta naught, which is this. Like this. So the problem we are solving out now is this beta 1 and this beta 2. Now here I need to open this bracket. From the process of opening this bracket, I'll be having summation x2y minus I'll be having summation x2bo like we have here. Then I'll still multiply this by this. I'll be having summation x1 x2 b1. This multiplied by this, give me this. This multiplied by this, give me this. This multiplied by this, give me this. Now here we are moving to this point. This times this, that means I'm going to have minus. Don't forget that this is x2. This is x2. This is x2. So now I'm going to have minus summation x2 square. Yes, that's what I'm going to have. x2 times x2 is going to be x2 square. Then I'm going to have beta 2. Don't forget that it's going to equal to 0. Here is my equation 3. Here is my equation 3. Now, this is my equation 1 here. This is my equation 2 here. And this is my equation 3 here. So, can I move on? The answer is yes. So let's move on. So now, I will need to analyze all my 3 equations. I will need to analyze all my 3 equations. This is the first equation. So let me write out those equations now. So the first equation is summation y minus summation bo minus summation b1 x1 minus summation b2 x2, which result at 0. This is the equation 1 I'm talking about here. Now the equation 2 I'm talking about here. Summation x1y, this, minus summation x1 bo, which is this, minus summation x1 square, which is this, with this, then minus this, summation x1, x2, b2, which is equals to 0. This is my equation 2. Now let's write out what equation 3 is talking about. This is my equation 3. So I have summation x2y minus summation x2 beta naught minus summation x1 x2 b1, then minus summation x2 square b2, which give me what? 0. This is my equation 3. Hope you are following me. It's not difficult. It's something that we can solve together. So now, these are my 3 equations. These are my 3 equations. So I would like, if you are following us, any step, you can just screenshot it so that you will not be confused. So that you will not be confused. So now I have my 3 equations here. So I want to rewrite this equation now. So rewriting this equation in the sense that I will need to move all these factors to the other side, which I'm going to have this as my dependent variable. So let's look at it together. So what I'm doing now is I will be having summation. I'll be having summation of beta naught. I'm just writing the equation minus summation of b1 x1. I'm writing the equation 1 now. Minus summation of b2 x2 equals to, sorry, this is going to be plus now. The assumption of the plus sign here indicates that these are moving to the other side. And when they are moving to the other side, your sign is going to change. This negative is going to result to positive. So and where this is not going anywhere. So that means I'm going to have summation. I'm going to have summation y. This is my equation 1. Then my equation 2. I need to write this equation. And by the process of writing this equation, I'm going to have summation x1 b0 plus summation x1 square b1, which is this, plus summation x1 x2 b2 equals to this, which is summation x1 y. This is my equation 2. And then move to equation 3. By writing this equation 3, then by writing my equation 3, I have summation x2 b0 plus summation x1 x2 b1, then plus summation x2 square b2, which equals to summation x2 y. This is my equation 3. Now, having my equation 3, these are my simultaneous equation. The easiest way to solve this simultaneous equation for this is by using matrices. Then I'm going to transform this into matrices box, where I'm going to have this. Now, from here, what the parameters I'm looking for will be here, where the value that I equates to is going to be here. It's going to be here. Summation x1y. This is summation x2y. Alright. This value n. Okay. I've eliminated this. I'll be having summation x1. I've eliminated this. I'll be having summation x2. Here I'm going to have solution x1. Here I'm going to have solution x1 squared. This place I'm going to have solution x1 x2. At this point, I'm going to have solution n, solution x1 x solution x2. Then here I'm going to have solution x1 x2. And here I'm going to have solution x2 squared. Now this is my matrices box coming from this. So if you apply multiplication matrices with this, by the time you multiply this by this, you are going to arrive at your simultaneous equation. So here stands for the column for my BO, here stands for the column of my B1, and here stands for the column of my B2. Now I need to look for change. What I mean by change is I assume that all these elements does not exist. So and if I find that I'm looking for my change here is going to be the determinant of this. I'm going to look for the determinant of these 2 by 2 determinants. That's my change. So my change here is going to be positive and negative. So in the process of looking for my change, I'm going to have summation x square 1 multiplied by summation x square 2. This is my change. Then minus this negative sign here, summation x1 x2. I'm going to have this multiplied like this is going to give me all square. I hope you understand. That is my change. Then I will look for my change in b. So 1, because the first thing is looking for my change, then I'll look for my change in beta 1, because now I'm looking for beta 1. To arrive at change in beta 1, all the elements under beta 1, you will need to eliminate it and substitute this value there to get our beta 1. Once again, to get your change in beta 1, all the value under the beta 1, we need to eliminate it and substitute this value there so that we can get change in beta 1. When you want to look for change, you don't need to substitute. You just assume all this does not exist. Then the 2 by 2 matrices here, you find the determinant, you arrive at this. But now we are looking at change in beta 1. So all the elements under the coefficients of beta 1 will be eliminated. Then we need to substitute this one there. Then what am I saying? Let me quickly have what I'm saying here. Now I want to deal with change in beta 1 now. We're still going to have n summation x1, summation x2, summation x1, summation x2. Sorry, don't forget that we have changed this. We are changing this to this. So summation y, summation x1y, summation x2y. Then this is going to repeat itself. Now, this is change. This is the matrices box of change in beta 1 because we have already eliminated all the coefficients under beta 1 by substituting what is here. So change in beta 1 now. I will assume that this does not exist. Then I'll find the 2 by 2 matrices of this to arrive at my change in beta 1. So to arrive at my change in beta 1, I'm going to have summation x1y multiplied by summation x2 squared minus, then we multiply these two, then I'm going to have summation x1 x2 then multiplied by summation x2y. So now I can get my change in beta 1. So now I need to get my change in beta 2. So my change in beta 2, sorry, I'll need to rub this off. So I need to get my change in beta 2. We are still going to follow the same process. Dealing with change with beta 2, I need to eliminate all the coefficients under the beta 2 and substitute this into it. That's to get my change in beta 2. So for you to get your change in beta 2, let me form the matrices box for change in beta 2. This will repeat itself. We don't need to change beta 1 again because we are dealing with beta 2 now. So now change in beta 2, let me substitute this here. So change in beta 2, we are having xy, xy1y, summation x1y, then we have summation x2y. Then this is a matrices box for change in beta 2. So now you assume that this line does not exist again. Then this will be your plus minus, find the determinant 2 by 2 of this. So by finding determinant 2 of this, I will be having summation of x squared 1 multiplied by summation of x2 y, then minus summation of x1 y1 multiplied by summation of x1 x2. So finally, to get your beta 1, your beta 1 will be equals to change in beta 1 over change. So your change here, your change in beta 1 will be over change. For you need to get my beta 1. What's my change in beta 1? My change in beta 1 is summation x1 y multiplied by summation x2 squared 2, then minus summation x1 x2, summation x2 y, then over the change. Then what's the value for the change? This. Then you have summation x squared 1 summation x2 12 minus, you open the bracket, summation x1 x2 all squared. Then to get my beta 2, that will be change in beta 2 all over change. Now what's the change in beta 2? This is change in beta 2. I'll be having summation x squared 1 multiplied by summation, yes, I'll be having summation multiplied by summation x2y. Then you subtract this, you have summation x1 y summation, okay, let me add this. Then I'll be having summation x1 x2 all divided by the actual change. Then what is the actual change? Summation x squared 1 multiplied by summation x squared 2, then minus summation x1 x2 all squared. Now we come to the end of derivation of OLX using 3 variables. Now please subscribe to our YouTube channel if you find this video useful to you. Thank you.